Would like to sit here? Your chair. No, it's not sitting. I will take this chair. Can I just take this and move also? No, you would stand and people come. Okay, so welcome everybody to the first auditorium event of today. I'm very happy to see a packed hall, especially a lot of young people. So this is exactly what the audience we expected. We also thought we'd let your parents come along, so that's good too. So here, this event is a very special event. If you go to auditoriums in astronomy open days, you hear talks about the universe, black holes, and stars, and so on. It's very rare you get an event where you mix science and arts or science and writing, and this is one of those very few events. And it's possible because we have with your Professor Biman Nath. He's a faculty member at the Raman Research Institute in Bangalore, which is in Meki Circle. And they're going to have their National Science Day on 28th. And that's also equally important because Science Day is celebrated because of Raman's discovery and as a Raman Research Institute. So you should definitely go visit there on 28th, at least to see his precious diamonds and so on, right?
More than that.
Much more than that, I was talking. Okay. Science as well, not just science. Okay. So Professor Biman Nath here is a cosmologist. In fact, he was one of my professors when I was doing PhD, so I'm very happy to have him here. He studies the universe, the thermal history of the universe, the gaps between clusters of galaxies, and so on. He studies a whole number of theoretical astrophysics topics. But when he's not doing that, he writes a lot of books. He writes poetry. He draws. He does say a number of things. He's published many books of fiction and non-fiction, both in English and in Bengali, including historical fiction as well as science fiction. And the latest book of his is called Solar System and Birth, published by New York Publishers. And we have Gangaram's people here to thank you for coming here. The Solar System Verse is a poetry book in English about the solar system, and it's fantastic. I read it. I had a peek at it before it was released officially, and it's a beautiful book meant for children. And we hope that it will kind of enthuse you to learn more about the solar system. So he's going to do some readings from his book now. And then after that, you're going to interact with the audience about any questions about the solar system or also about his writing process. So please treat him as a scientist and an author at the same time. So questions can come about both the science in his poetry and the poetry in his science. And with that, I welcome Biman Nath to now do his book reading. There are some 65 or so copies of his books available here. The publishers from Gangaram have kindly brought to us, and he'll be signing them after that here. Okay. So, and we have our volunteers here who will help pass the mic around for questions and all that. So once he finishes, we'll have an interactive session with all of you. I hope you all enjoy it as much as I enjoy the book. So, Biman.
Thank you, Lulu. So, good morning and thank you all for coming. Sunday morning. And thank you, Neeraj, for inviting me and giving me this opportunity to talk about this book and read out from this book. And I would like to thank the organizers in the Indian Institute of Astrophysics for giving me this opportunity. So, what I thought, instead of waiting till the end for interactions, it's probably going to be more interesting if you stop me. Let it be an interactive session.
Can you hear him at the back now?
Can you hear me? Can you hear me now? Okay. Louder. Fine.
Okay, so, turn down max.
What I thought, it would be more interesting if we have it as an interactive session all the way through and not wait till the end after I finish.
Okay.
So then, when I'm talking about some topic, then if you have some questions.
Sorry, last one, do you want to use this?
Okay.
Would that be okay with you?
Fine, sure.
This is okay.
So then I should switch it off.
Yeah, no, but we need for recording. No, it's okay.
Okay. Right. So, what I said that, let's not wait till the end to ask questions. Let's, if you have, so as I go from topic to topic, if you have something in mind, you can pose the question, and I'll try to answer as much as I know. It's not that I am Google or something. I know everything. So nobody knows everything, right? So this book is a different kind of a book, and I wanted it to be a different kind because, first of all, nobody really talks about solar system. Everybody talks about black holes and Big Bang of the universe and galaxies. Usually solar system, which is in our backyard, is sort of neglected. Planets, everybody knows the planets, and it's like that kind of an attitude. So I wanted to write about solar system. This objects that we don't really talk about often. But there are many interesting things about those planets. There are things that we don't know yet about these planets, and there are questions that people are still struggling, and which is why there are lots of interplanetary missions, for example, going to different planets and different satellites, etc. So, what are the questions that are in the minds of astronomers right now? And I wanted to write in a different format, so I thought I should try in verse. The way, I don't know whether it works. The readers, you the readers will be the final judge of whether that sort of format really works or not. But I wanted to try it out, and this is written in pentameter, so 10 syllables each, so that one can read it aloud. There is a sort of rhythm to it. There's a sort of a natural rhythm of our the way we speak, right? The pentameter. This is why, for example, Shakespeare wrote in the sonnets in pentameter. So there are different. The topics are like in solar system, the objects that we encounter, beginning from the sun and the planets, asteroids, comets. Then I have also talked about what we know about the origin of the solar system, how and when it had begun, and whether there are planets, other stars also have their own planetary systems or not, what we call the exoplanets these days. There's a brief chapter on that. And then where is our solar system in the whole universe, to give you an idea, because so in the scheme of the universe, where is our solar system? And that's how I end. So shall I read from starting from, just some excerpts from the book. So this is how I started. This is the story of 8 round planets, a few rocks in between, and some comets. The sun sits in the hub and holds them tight. What's more, it makes them all shine with its light. Solar system, this family is called. By the sun's gravity, all stand enthralled. The Earth is a member of this system, one of the planets, the third among them. Let's go meet the planets one by one, but first let us learn about the bright sun. So then I start with the sun. I just hope that reading like this, if we can read out to a child, the way, for example, we read them in the stories at night, bedtime stories. They might like the rhythm, and they might, and the idea. One of the things that I have done in the book is that usually in textbooks, for example, the way they learn about solar system, the planets, a lot of information. Oh, this planet is smallest, this planet is largest, this planet is farthest, this planet is this color, the planet has got this color, etc., etc. There's a lot of information. But the information doesn't really make sense to put them in the head unless you want them to start asking questions. So this book is more about questions than about the answers, because the answers are there in Google these days. So, and what's more, I tried to write about the open questions that are still unsolved, for example, so that one of the readers, some of the children here who will read and who might start wondering about these questions might go become an astronomer and solve those questions and find the answers to those questions. So that's the open questions was something that I had in mind, I kept in mind. So the sun. The sun is a star, the jewel in the crown. And a star can produce life of its own, light of its own. But for this to happen, object must be extremely hot as well as heavy. Stars are fiery spheres of gas, large and round, by their own gravity, heated and bundled. So among the stars, sun is average. The sun is not a very hot star, not a very cool star, or it's not a very massive star, it's not a very low mass star. It's somewhere in the middle, you know. When it comes to temperature and age, 4.5 billion years before now, it began to shine as a star. And how? So then I start talking about its temperature in the center, and then how it's shining, what's the nuclear reactions that are producing the energy of the photons, of the light. So near its center, the heat is intense, far, far beyond what we could ever sense. At 15 million degrees Celsius, the core temperature is enormous. In such heat, atoms find it very hard to keep the electrons in their backyard. So what happens in this temperature? Because the movements of the particles, atoms are so hectic, they lose electrons, right? So it's what we call ionized. Without electrons, the bare nuclei, the nucleus of the atoms, in great haste, they continuously fly. The heat and pressure changes elements by fusing them into large variants. This fusion produces at the sun's core one helium nucleus from hydrogen 4. Okay, so here I had some. So these are the planets, and this is the sun we're talking about, and this is nuclear reaction fusion happening. So you can think of 4 hydrogen nuclei being fused into one helium nuclei, and in the process, what happens? But there is a great price for this merger. Energy is squeezed out of matter. Matter makes an energy donation for the cause of element production. This energy is given off as light and makes all the planets appear bright. So that's where the E is equal to mc squared comes in, as some of you know. For matter and energy make a pair. E is equal to mc squared. M stands for mass and E for energy. Physicists write the speed of light as c. That's what Albert Einstein formulated. Matter and energy are related. So this is how sun produces its light, and then let me see how. Then I talk about, for example, the storms, the solar storms that you see that appear on the surface of the sun. So giant storms on the solar surface vast launch violent winds that are strong and fast. This solar wind can be very potent. Even near the Earth, it's important. It carries particles energetic and slams into the Earth's field magnetic. At the poles, these particles generate colorful and dazzling auroras great. So these particles from the solar system, they hit our Earth and they are channeled into the poles, which is where they strike the atmosphere and then excite the molecules of the atmosphere, and then they shine. And that's why we see the auroras. Okay? So now there are places in the sun one can mark which appear to be shaded and dark. They're not really black, but less bright compared to the rest of the sun's light. These dark dots in the sun look like black clots due to their appearance. We call them sunspots. So the sunspots are intimately connected with the solar storms, and then I have explained that. Right. Let's go to the next. So these are the sunspots. Sunspots are connected to the solar storms, and that's the size of the Earth in comparison. Then comes Mercury in the list, the first of the planets, right? The closest to the sun, and so being closest to the sun, its speed is the fastest among the. First comes Mercury, the planet closest, and it moves around the sun the fastest. And there is a reason for this, right? The closer to the sun is your orbit, the faster you move, or heavens forbid. Gravity of the sun will make you fall. Nothing whatsoever will help you stall. So you have to keep, since the sun's gravity is strongest there, right, for the closest planets, it has to move fast, just to keep away from, avoiding to fall onto the sun. But in our sky, Mercury is hard to sight, being close to the brilliant sun's light. I don't know how many of you seen Mercury. Has anybody seen Mercury? I probably. Okay. It's very either during just before the sunrise or around sunset. You must have seen, right? So it's very close to the sun, which makes it very hard to see and spot. And it is also a small planet. So in our sky, Mercury is hard to sight, being close to the brilliant sun's light. If you care to watch the sun rise or set with a clear horizon, you may get to see Mercury with its muted light, not far from the disk of the sun so bright. So then I talk about Mercury, its structure, what makes it, what it is made of, and why. Okay, and this why part is very important in the book. It's not just enough to know that Mercury is made of this, such and such things. Why so? Why are, for example, if we look at the planets, there are 4 planets. The inner planets are rocky, right? Mercury, Venus, Earth, and Mars. And the outer 4, Jupiter, Saturn, Uranus, Neptune, are all gaseous. Now, as an information, one can just learn this as a for school exam. But one can ask why. Why is this? The inner planets are rocky and the outer planets are so gaseous, and they're also huge, giant balls, like each of them, Jupiter, Saturn, Uranus, and Neptune. There is a reason why, and I talked about that. Then talked about, for example, Mercury's orbit is a very interesting thing. Other orbits are, for example, the orbits are sort of fixed in space. Mercury's orbit goes like this. It doesn't close, the loop doesn't close. So what we call it precedes. Okay. So, right. So you might think that it is good for nothing, the Mercury, but Einstein found the planet blessing. He wanted his theory to be proved and found a clue in the manner it moved. I'm talking about the theory of gravitation that he came up with, in which gravity is not a force, but there is a space-time, and space is curved because of mass. And that curvature of space makes planets move around orbit, and that was his new theory. So he was looking for a confirmation how to prove this, and he found that he thought that the Mercury's orbit of Mercury can prove his theory, because this cannot be solved. This cannot be explained in any other Newtonian theory, for example. So its strange orbit doesn't quite close the loop and dances like a cosmic hula hoop. Astronomers had long puzzled over Mercury's orbital behavior. Einstein had figured this happens because gravity doesn't quite follow the laws of Newton that we have learned in our schools. Rather, it changes geometry's fixed rules. So, according to Einstein, the space has a geometry, and the geometry is different. If it is close to, it becomes changed if it is close to a gravitating mass. And in that sort of curved space, the orbit of Mercury is such that it doesn't quite close. So the gravity of the sun distorts the space in which planets' orbits find their place. Gravity bends space, makes creases in it, and consequently affects the orbit. This bent space affects Mercury the most because it is the planet innermost. An orbit in space that's much distorted can dance like Mercury's, as reported. For Einstein, Mercury's dancing circuit gave his theory a clear verdict. So this effect is not so pronounced. It's most pronounced in the case of Mercury because it's closest. In the case of Earth, we are so far from the sun that effect doesn't really, it's not so pronounced. So the next planet is Venus. Okay. The Venus is second in the planets list, covered in a veil of thick clouds and mist, of gas, poisonous and acid rain, which have turned out to be the planet's bane. All these gases trap the heat, make it hot and unlivable like a bubbling pot. As you know, the temperature of Venus is very high, and because of its clouds, So it is the global warming in action, right? You can see that, that's what has happened. That's what might happen to Earth if we are not careful, right? So I'll talk about that also later. So then I talk about, for example, taking a child on an imaginary trip to the Venus. Suppose it's very hot, very high pressure. So what would happen? Suppose we want to go to Venus. Right? So think of a trip to the planet Venus. The adventure would be greatly grievous, mostly grievous. The air on it would smell like eggs rotten. And your back, the air pressure would flatten. The pressure is so much, they will just flatten your back. You would be smashed down on the sizzling ground because it's hot. Forget about ever being earthbound. There's no chance of coming back. Venus is so hot that even hard stuff like lead and tin melt away, sure enough. Okay. So then I talk about how global warming may actually happen on Earth if we are not careful about our climate. So our Earth may one day become hot like this if we foul the air and cut our trees. Greenhouse gases like carbon dioxide will start this slow, steady, and downward slide of the state of our own atmosphere, which will leave us with nothing to cheer. Carbon dioxide lets in the sunlight, but gives the thumbs down to the heat at night to escape from the scorching hot surface, which thus makes it an unbearable place. The plight of Venus should make us reflect of how we are treating our own planet. Dumping pollution around us one day will only lead to great dismay. Global warming is sure to make our fate a horrible one at a future date. Earth will become another hot planet if we kill our future and don't plan it. Thank you. I think this is an important message, at least for the new generation, they are going to take care of this, that we are living in such a mess. So then comes the planet, Earth. Then comes the blue planet we inhabit. It has precious water that makes it fit for life to populate every corner and for a species like ours to prosper. That's the important thing about Earth, that it has got water, not steam, not ice, but water, right? In the liquid form. And the liquid form is very important because, and look, there is water in liquid form because the Earth is relatively warm. It's not too hot and it's not too cold, helps the chemistry of life to unfold. Right? Water has this stunning quality to dissolve everything and prepare a stew. No other substance can do this magic. Without it, life story would be tragic. Okay. So that's the important thing about the Earth. And of course, this is the water. And then of course we have beautiful moon as our satellite. It's a very unique satellite in the whole solar system. No other satellite has, if you look at the ratio of the mass of the satellite and the planet, this is the largest ratio. Okay, so no other planet has such a big satellites compared to its own mass, which is very unique. Which is probably the reason people think about the origin of the moon. It's not so straightforward. So people have started thinking about the origin of the moon. So this is our moon. And I talk about the moonscape. Why is it dusty, gray and dry? And the orbit of the moon, for example, it changes. Yeah. The moonscape is dusty and gray and dry with almost no air. It has a dark sky. Craters abound on it. Marks of an age when bombarding space rocks had ruled the stage. So these are craters because of the impact of the meteors, right? Which also affected us. But on the Earth, the marks of those impacts have gone away because of the erosion, right? The atmosphere helps the marks to go away. But on the moon, there's no water, there's no air, so the marks remain there. So it's like a fossil of that age when such bombardments were very important. And then, of course, the phase of the moon, I try to explain in verse. For example, the moon always appears to change its phase during the time of almost 30 days that it routinely takes to go around from tiny crescent moon to full moon's round. When the sun behind us, shines on it straight, the full moon dazzles like a glowing plate, right? That's the full moon. We see a full moon. And when the sun shines, casting light on one side, here and here, we see a half a moon with a clear divide. And when the moon has the sun behind it, for example, here, the side facing the earth remains unlit. So we see a new moon. We don't see it. Right? That's the new moon. And then I talk about the tides. And then I talk about a very important structure of our earth, which has probably been very important for the emergence of life and other things. For example, it has got plates. The crust of the earth is divided into plates, and the plate tectonics, which is not there in any other planets in the solar system, which is very unique. So the earth has a structure exceptional, which may have helped in life's arrival. The thin top layer has soil, rock, and dust. All these make up the life-sustaining crust. Below this layer, there is a boiling pot of bubbling and molten materials hot. The crust has cooled down as an outcome, fragmented into parts it has become. The pieces are called plates, and they can slide over the molten material inside. Okay, they can just slide over. And when the sliding plates collide or just shake, then the crust vibrates. We call it earthquake. Sometimes the sizzling matter finds a way to emerge out of the surface and spray. Volcanoes bring out the material much needed for our life terrestrial. This is important. The volcanoes actually serve a very important purpose. And it's possible that the life first emerged on Earth on underwater volcanoes, underwater vents, where the water is hot and you can still find bacteria and other life forms. So it is possible that the life probably first formed there, what we call the extremophiles. So the planet Earth looks like a pale blue dot. That's the phrase that made famous by Carl Sagan. The planet Earth looks like a pale blue dot in a faraway photographic shot. You may have seen the bookmark being sold outside. It has this pale blue dot picture. This is home for us, and the only place where life is known in the vastness of space. The factors that have ultimately led biomolecules on the Earth to spread are far too complicated and diverse. It is likely rare in the universe. Careful we have to be and cautious so that all the pollution hideous doesn't devastate our fragile sphere, lest life should completely disappear. So then comes Mars. I don't know how much I need to do inside. So then Mars is the last of the rocky planets. I talked about the 4 rocky planets in the inner set, right? Mars, the last planet with a rocky bed. Iron in the soil makes it look brick red. It has icy poles. It's got the icy pole. It has icy poles as we have on Earth, of cold and frozen water. There's no dirt, but there's no liquid water, by the way. Now scientists are thinking of studying whether there was liquid water at some earlier point or not in time. And so I talked about why is Mars the way it is now? What is all the water gone? What happened to the air? So this is connected to the history of the solar system, and I have tried to explain it here, but I won't go in. But for example, studying the orbit of Mars, for example, gave the scientists like Kepler and then Newton the idea that, the idea of the theory of gravitation, that the gravitation can explain why Mercury's orbit is like this. And Kepler discovered that the orbits are not circular, but they're elliptical. that came from the study of the Mars. In that way, Mars is important also. So observing Mars has helped us to know how the planets move with satellites in tow. Orbits were imagined as circular earlier, until revised by Johannes Kepler. It is not a circle with a center, looks like a deformed circle, thought Kepler. Then he discovered his orbital laws, in which till now none have found any flaws. The orbits were then explained by Newton by a force that he named gravitation. It makes things fall on Earth, causes the tide. From gravity, surely nothing can hide. Yeah. So then I talk about the spacecrafts. So in every chapter for every planet, I've also talked about what are the probes that have been sent to these planets. For example, starting from Mercury, it's very difficult to send probes to the Mercury because the orbits are very unstable. Venus is very difficult to send anything down there because of its hot temperature and pressure. Mars is easier, so people have been sending probes on the Mars, and then, as everybody knows, the rovers which have been going around taking pictures, right? They've even sent a helicopter to Mars now, right? So we have sent spacecrafts to the red planet, and a few have successfully landed on its ground to do experiments with the soil material and its contents. The idea was to look for a sign of life. It could be hostile or benign. Rovers on Mars have since then descended. They have moved around and taken candid pictures of the planet, wide and detailed. However, all attempts have so far failed to find even a slight indication of life forms or metabolic action. But the search goes on with more advanced probes to detect a Martian life form, one hopes. And then comes the asteroid belt in the region between Mars and Jupiter. So if one looks at the solar system's map, beyond planet Mars, there is a big gap. There is an asteroid belt that comprises rocks and boulders of varying sizes. There are plenty. Each is an asteroid, moving like minor planets in this void. Now I talk about how did this asteroid belt come about? Why is there an asteroid belt between Mars and Jupiter? And it turns out that the Jupiter being so massive, this is the most massive planet in our solar system, that created all the problem. There was pulling because planet could have formed here unless Jupiter weren't there. It was like bully in the school playground. They won't let others play. So they won't let planets form there. So it kept breaking up because of its gravity, strong gravity. So didn't let anybody, any planet to be formed there. So, so I talk about that. So are these pieces of the belt asteroid remnants of an old planet destroyed? What can cause a planet to be absent, yet make rocks, small and big, to be rampant? It may be that a planet's building blocks couldn't merge, and they continued as rocks. Pieces of rocks have to consolidate for a planet out of them to create, right? The rocks have to come together and merge, and so that the planets can form. And if you have a bully in the ground, which won't let any team to be formed, that will keep, breaking that team. So, that's why there's no planet. So sadly for the rocks gathered around here, the massive planet Jupiter was near. Jupiter bullied the rocks close to it, put a stop to their forming a planet. Okay? And then there's lots of story. One can talk about the dinosaurs, for example. The asteroid, one of the giant asteroids fell on Earth, right? And the dinosaurs were extinct. Then we keep looking. So, for example, there is this story from 1908, right? An asteroid fell in Tunguska in Siberia. So sometimes these pieces of space rock get nudged from their respective orbits, get dislodged. If they happen to come near Earth and hit us, the impact may cause planet-wide chaos. A big asteroid fell near Mexico roughly 65 million years ago. Dust covered the sun, the only light source, which first killed the planets and the dinosaurs. Another asteroid fell in Siberia in a remote area named Tunguska. One morning in 1908, it burst and produced an explosion great. So you can talk, you can read about the Tunguska event, which is still sort of people still try to understand whether it was a comet or an asteroid, for example. So these asteroids, some of them fall on Earth. We call them shooting stars, and if you find a fragment, you call it meteorite, and you study the meteorite because that might tell us about what was the solar system like. This is like a fossil of what that age, the ancient age of the solar system. So if you study these meteorites, you can find out about the history of the solar system. Right? So put under microscopes, these rocks lead on to knowledge of the past, ages bygone. Pieces coming from the asteroid belt contain the primal stuff that did not melt. So one can study, sitting on Earth, the story of the solar system's birth. So that's how scientists, for example, know what was there in the beginning of the solar system. What was the composition, what were the materials, etc., etc., studying these meteorites which fall on the Earth. Okay? And we move on to Jupiter, the largest planet. Jupiter is a giant. Could have been a star, but it missed by a small margin. 1,000 times lesser than the sun's weight, is the biggest of the planet's 8. Lacking a hard surface of rock or stone, it marks the border of a gaseous zone. Past the orbit of Jupiter, the bulk, objects are made of icy gas in bulk. So the reason is that the young sun had a quite turbulent start, blew the gases from the solar system's heart. So the solar storms were very intense those days. So the solar wind and the solar storms basically blew away all the gas from the inner region and made all the inner planets rocky planets and kept all the gas to the outer portions, that are all the outer 4. So this made the inner planets rocky, small, and the outer 4, each a gaseous form. So, all right, so I'll quickly go through this. So I'll talk about Jupiter's moons that were, 4 moons that were discovered by Galileo. So this is Io, this is Europa, Ganymede, and Callisto. And each of them have very important characteristics. For example, you may have heard about, people are talking about Europa. Europa has got, this is the Europa, and then there may be life possible under the icy surface. So people are talking about that, and I have talked about why do people think so. But I'll quickly move on to other stuff. This is Pioneer 10 and 11, which went past Jupiter in the 70s. So 2 sister probes in the 1970s were sent to study it with amenities, to take pictures and experiment around the Jovian environment. Pioneer 10 took pictures vivid, found the planet primarily liquid. If gas is put under pressure profound, it turns into liquid, it has been found. Okay, so that's how people have found about Jupiter, and then we come to Saturn. Interesting thing about Saturn is a gas ball, like Jupiter, not quite the same size, a little smaller. It is rather fluffy and light in weight. It would float if you could somehow create a pool of water in a big bucket and try to dunk this gaseous planet. So Saturn is very light, density is very light, so it will float on water. So then, of course, the Saturn has got rings. Galileo was like stupefied to find this. He thought there were 2 years coming out of this. Is how he sketched. But then people realized that there are actually rings, and the rings are made of. So the Saturn has the most unparalleled look. Galileo wrote down in his notebook, the view through his telescope baffled him, a pair of ears sticking out of its rim. Later, people realized it's a disk made of matter with movements slow and brisk. The splendid rings had originated from moons and comets that were fragmented. They're made of dust and rocks, coarse and fine. There are shepherd moons. So there are moons which are called shepherd moons to keep them in line, okay, so that they don't get dislodged. The rings have gaps, each like a groove, where the pieces are not allowed to move. So that's about the Saturn, and then I talked about Titan. Titan is very interesting. It's the largest planet, and it has got methane, and there are probably methane rains, which so like our water cycle on Earth, there's probably a methane cycle on Titan. So I talked about that. I'll quickly move on to other planets. This is Uranus. Uranus is very interesting. It is it spins, but like a rolling pin, like on its side. It spins like this. Okay, instead of spinning like this, it spins like this. So so Uranus has an offbeat way to spin, turning on its side like a rolling pin. Perhaps an impact. Now the question is, why does it happen? Why did it happen? It's not enough to know that it spins like this. It's important to ask, why did it happen? So it must have, something catastrophic must have happened to it to make it spin the other way around. Venus, also I talked about, also spin the other way around. Every other planet, for example, as it goes around, it spins in the same direction as its rotation. Venus is other way around. Okay, so that in Venus, you will have sunrise in the west and the sunset in the east, because it spins the other way around. Now the question is why? It's more natural to have the same spin, the direction of the spin as in the revolution direction, but it is not so in the case of Venus. So that means something happened, something special happened to Venus. Maybe a collision, maybe, so the similar thing in, for example, Uranus, right? It spins on its side. So perhaps an impact with the passerby does this extraordinary spin imply? So then the question of because Voyager 2 and 1 and 2 when past then the question of, for example, the color. Okay, so because of its spin, seasons there last long because of the tip. See, seasons are important for the tip. It comes from the tip, right? So because if you tip it like this, then the seasons are going to last longer, okay? So which makes the far side temperature dip. Being in the shadow for a long time, when it turns, and the heat can slowly climb. So the seasons are longer, and that is a reason for its color. Such a contrast of cold and heat can shake winds vigorous on the planet's landscape. The difference between the hot and cold side, that produces wind, right? The pressure of the air, and that produces wind patterns, etc., etc. So gigantic turbulent storms have been seen on the surface of this planet, bluish green. The heat on the illuminated side spreads methane in its top layer far and wide. The haze of methane gas makes it appear practically spotless, a turquoise sphere. Okay, the reason why Uranus is so spotless is because of this tip, because of the seasons being longer, etc., etc. So everything is connected. Okay, so right. So Uranus. Let's go to Neptune. Because you have to right. So Uranus, when they studied, Uranus was discovered by a telescope. The first planet to be discovered by a telescope, which was beyond our naked eye visibility, right? So there was something odd about Uranus. This is Uranus. Okay, this is Uranus orbit. And when they studied the movement of Uranus in its orbit, they found that, so let me read out. There was something odd about Uranus. Its wobbly orbit made it infamous. Newton's gravitational theory became focus of scientists' jury. This movement of Uranus could not be explained only by the sun's gravity. Another planet was deemed the culprit, tugging Uranus off and on a bit. So they realized that the orbit of the movement of Uranus was not uniform. So they thought that there's some other planet must be there, because otherwise you can't explain it to Newton's gravitational theory. So there must be some other planet which is tugging on and off, and which is how they predicted where that the suspected planet would be at a certain on a certain day, certain time. So this was the simple sole explanation from the theory of gravitation. Scientists calculated where it could be and got themselves the telescope ready, discovered at a moment opportune an icy giant. It was named Neptune. So that was the tributary of Newton's gravitational theory, for example. Okay, and the Neptune being the, so this is Neptune, and being the last of the icy planets, big planets. Interesting thing is, if you look at the temperature of the planets, you would expect that the temperature goes down, right? It will go down as we go further and further because the sun's radiation is going to be less and less. So you expect that the temperature of Neptune should be lower than the temperature of Uranus? Well, it's not so. It's not so. And then ask you why. And it turns out, it's being in the, so far out, it is still going through the process of planet formation. It is still getting hot from contracting. The planets as they form, right? It's just forming the planet, and the gravity is going to make it contract, make it hot. You press anything, it's going to become hot, like just like a bicycle pump does, right? So Neptune is still going through this process of planet formation, which is why it is slightly hotter than it should have been. So it is not as cold. That's interesting, the planet is still forming there. So being the farthest one, Neptune is still going through the planet formation drill. It is still changing under gravitation. Its core is subjected to contraction. The warmth that comes out of this slow shrinking is enough to be a source of heating. Okay. All right, so, and then beyond Neptune, we have a region populated by what we call the trans-Neptunian objects. And Pluto was a planet, and now we think that this is just one of many, the trans-Neptunian. So I've explained why Pluto is not a planet, what a planet should be, and why Pluto doesn't fit the bill. Okay, so but that will take too much time. Then these trans-Neptunian objects are also basically the comets. Right? Now, comets are also very interesting objects, right? If you look at the comet, for example, there are two tails, by the way. I don't know how many of you knew that there are two tails. One of them is dusty, and this is a straight one. It's fainter, and this is straight, and it's made of ionized gas. Okay, this one is slightly bent. Okay, so I explained why. This is because the sun, the sun's radiation is keeping it straight. Okay, and then why, for example, comets are interesting. Let's see. So let me ask you a question. Did the comets bring to Earth its water? It's a question that makes one wonder. This is a question that people have been asking, including Carl Sagan, who started this question, for example, and wrote papers on the amount of water on Earth is a mystery. Where does it come from? And it's still not known, and people are trying to find. So one of the questions, one of the this thing is, maybe the comets have deposited the water. Right? So some comets have been noted to contain complex molecules strung like long chain. Complex molecules that are important for life, for example. Some of the comets have been found to contain those ones. Some of them are very complicated, like the ones that life on Earth created. Did these prebiotic molecules seed life on Earth? Another puzzle indeed. This is also something that people have been wondering now, whether life has, at least some of the prebiotic molecules have come from outer space. So Edmund Halley. So earlier people used to think that omens. So folks of the past thought comets as omen, objects far outside nature's domain. Halley, friend of Newton, first recognized that orbits of comets are organized, similar to planets, but rather stretched, okay? Cutting across the paths of all planets. It's what makes them, proclaimed Edmund Halley, appear in the sky periodically. When they're close to us, comets appear in our sky like a bright visitor. As they come and go, by the way, as they come and go, they leave a long trail. So here is, for example, the trail of a comet's dust. As it moves, it keeps shedding its material, and there's a trail of its debris. Okay, and when our Earth goes through the orbit of the Earth, cuts one of these comet trails. So these are all dusty objects, right? What we see? We see a meteor shower. So this is a picture of IAA telescopes in Hanle, the Indian Institute of Astrophysics, and there's a meteor shower there. So as they come and go, they leave a long trail of debris of rocks that fall off the tail. These rocks sometimes cross the orbit of Mars and cause beautiful meteor showers. Okay. All right, so then I talk about how did it all begin, then talk about where is our solar system in the universe. So, is there some time? Okay. So what lies beyond this system, you might ask? Knowing the distances would help the task. Then I talk about how to measure distances in space, for example. We don't use centimeters or meters and kilometers because we'll be talking about billions and billions, right? So to measure, we need a special yardstick that won't torture us with numbers so big. Miles and kilometers are of no use. Billions and billions would rather confuse. So you use light speed, light hour, light year. Okay, that makes the units simpler to talk about. And then I talk about where is our solar system in the whole galaxy of Milky Way? It's a small part, and right. And then I talk about what about planets around other stars. So now it appears that many stars, and in fact, probably all stars on average will have some planets, maybe. So that's a question, is our solar system unique and rare, or are there many in the cosmic sphere? Astronomers have long been searching for neighboring stars with planets to explore. Recent studies have led them to conclude that exoplanets are a multitude. It's possible that on average, all stars have planets around them, big and small. Several thousand planets have been found within a few hundred light years around. They have also found that there is no dearth of planets habitable like the Earth. Some of them may turn out to have water in liquid form and also harbor some species of life, though it may be tough to prove beyond doubt and be sure enough. So, and then I end with an epilogue. The solar system is small in the scheme of the whole universe, but it does seem, for one reason, to be significant. It contains life. That is important. Not only life that vegetates and grows, but also a zeal for knowledge it shows. As we venture to survey the planets, to find out more about distant objects, and as we discover more of the sphere that we live on, a puzzle does appear. How small is the world that holds all of us? At the same time, how unique and precious. So that's how I end.
Thank you, sir, for the wonderful book reading session. I could see the wonder and amazement on many of their faces, and it just reminds all of us how amazing astronomy is. Before we can take some of your questions, I would like to announce that there are bookstall set up outside the auditorium, and even in the front lawn, you can buy sir's book, and he will also be available there for signing each of your copies. So, sir, will take some questions.
Yeah, as much as I can.
Yeah, for like 5-10 minutes.
Sure. He has been very good.
Mercury takes 88 days to revolve around the sun, 88 Earth days, but its one day is 176 Earth days. Why?
Compared to the Earth, it just happens to be so. Okay, because it's moving so fast.
So I've had this question for a long time. I have read somewhere that in a few 100 million years, our galaxy is going to collide with Andromeda galaxy. So, sir, what is the reason that we're working towards such, like gaining such information, sir? It makes you feel so little, but it's all going to go away sometime.
Well, it's a long time from now.
That is a long time.
Years, right? Yeah.
Well, like I feel in a lifetime, somebody can apply only so much. So, what is your inspiration to follow all this?
Well, as you said, it makes you feel humble, right?
It does.
So that is one of the things that an astronomy does. I mean, if you look at the starry sky at night, you see that you are small. You are not so big, and we're not so powerful that we should be treating the planet, for example, with such arrogance. Being humble is important, so that we treat whatever we are living with care and with love. Doesn't that help? So I would say, astronomy helps in that manner. It makes us less arrogant. We should.
Yes, sir.
So maybe
I don't know how you feel, but the things. Thank you, sir.
So like for Mercury, right, when you started, it's like closest to sun. So more, it feels more natural or intuitive, like the more closer it is to the sun, more symmetrical should be the forces around it and more symmetrical should be the orbit. But like it's completely off. So
well, that's one way of looking at it, but it's also true that the sun's gravity would be because it's close to the sun so much, the closest to the sun. So the curvature of the space due to sun will be felt by Mercury more than any other planet. So and being in that sort of, it's like a belt tarpaulin in which it is trying to move.
yes, but isn't it? I mean, isn't whatever space time we're talking about?
Yeah,
Could be more
it is symmetric, but then you have to talk about its own motion in it. And it is symmetric when you say 360 degrees in this direction, but it's not symmetric this way. So it keeps falling, and then it doesn't close the loop, which is why. So it is like as they do this in circus, right? They have a pit where they go around with motorbikes, for example, right? They don't really close the loop, for example, they keep going around.
Yes, correct. One thing is about closing the loop. Another thing is like the sun is still not in the middle of the orbit. Right?
Oh, yeah. Okay, that is a very small division. That's very, very small. It's the picture I showed here it's very, very exaggerated. Yes, yeah, you're right. So that's a very exaggerated way of showing it. So the epihelion and the perihelion are not so different. It's more or less circular, but there's a difference. In fact, all the orbits of all the planets are more or less circular. The deviation is very, very small. Yeah. Yeah.
Andromeda is going to collide with Milky Way. Is it theorized or how did they find out it is?
Okay, so there are many ways of looking at. So we know the speed of the Andromeda galaxy, the relative speed between us and the Andromeda galaxy, and we also know the direction. So once we know that, we know the relative speed and you know the direction of speed, right? The direction in which it's moving, then you can figure out what's going to happen. So right now it's theory. You're not going to survive to test the theory, by the way. So, but there are people who write papers on, by the way, what will happen to this solar system in the case of that in such a collision. And according to some astronomers, the solar system might actually migrate to Andromeda, and we will see this Milky Way from there on. I mean, so there are questions here.
Before the first satellite was sent into space, somebody must have discovered it. Who was it?
Who was it? Who was it?
The first satellite that was sent into space. Somebody.
Artificial satellite.
No, who discovered space? Who discovered space?
So, who discovered space? I don't really understand the question. Somebody you said satellite, sending a satellite.
Before the first satellite was sent,
Yeah.
somebody must have discovered space.
Well, so the idea of gravitation was there. We know how gravitation works. So people figured out that, if we send something, so it's like we know how to, for example, if we throw a stone up, right? Depending on its speed, etc., what's going to, if you don't throw it with a high speed, it's going to come down. But if you throw it at a high speed, it might just go around the earth. It is just comes from the theory. Where as you study in class 10, 11, 12, when you study projectile, you will realize that this is bound to happen. So somebody tried out and then sent an artificial satellite. It all comes from gravitation.
Thank you.
Thank you.
Why can't we see Jupiter's rings like Saturn?
Oh, the Jupiter has rings, but it's very thin. You have to have very large telescope for that. A small telescope will not give you. The Saturn's rings are big.
But Jupiter has more mass, so it should.
So it has more mass, but so what caused Saturn's ring is that some other object came too close. That may not have happened in the case of Jupiter. That sort of accident. Right.
No, we'll continue with, he'll do signing and questions, because people are waiting for questions.
Outside?
No, we'll bring it in. We'll bring it.
No, because they asked me to bring a book.
This kid has.
Yeah, of course. No,
You can
No,
continue.
we're continuing anyway, but
Okay.
people want this autograph.
So we'll do the book signing.
Yeah, here. Please carry on. Please.
Sir, how does this sunspots form in the sensor?
Check.
So there's something called magnetic field. Okay. And there are places on the surface of the sun, where the magnetic fields are very high. Okay. So it's a very strong magnetic field. That's where that magnetic field being very strong, it makes the gas there slightly cooler. Okay, and that's we look at it as like sunspot.
Thank you, sir.
And you can see sunspots downstairs. We go here, the lodge here, we're showing sunspots. Okay. Now, so how was the experience? You wanted to write more books? Yeah. Yeah, there you go. So what we're going to do is we have some books outside. You can buy a copy of the book, bring it inside, and he'll sign them, but he'll also continue answering questions. Okay, so he'll be sitting here. Biman, please. He has a pen. So you can continue asking questions. You also continue to ask him to sign the book. Or to sign the book, you have to buy the book. Okay. We don't have too many books on sale, so you can also place the order with Gangaram. They can also send them to you later. Okay. Now you can continue moderating the. Sit. Yeah, let's make a queue. We have a queue for book signing. We have a queue there for questions. So people want to ask questions, you can hang out here. He'll be here till 6 p.m. Okay. So after coming up, so we buy the book.
Yeah, you buy the books outside, get it in for signing.
Yeah.
Adya.
Yeah, okay.
I want to introduce my brother. I think.
You had a camera.
Question. Why don't Saturn really fall into Saturn? What keeps them together?
So this is the shepherd moons. There are slightly bigger objects inside space. Which keep them alive.
So why don't these shepherd moons fall into Saturn?
So they are moving very fast. So they are the moon. Why doesn't moon follow them?
Those moons rotation speed is high enough to stay away from Earth.
So it's the same thing. Same thing. So the whatever else of the rings, those more icy objects, also going
Sir, yes.
Sir, some of them have few questions, they're waiting for you.
Yeah.
How many black holes are there in the Milky Way?
Oh, there is definitely one in the center, which is very, very big, but there are probably other smaller ones.
There's many black holes.
There are astronomers in this institute who work on, so you are working on one. So there are a few different.
Not it.
One more question. So there's one more question.
What would happen if the moon was not there?
Let's think about what are things that happens on Earth because of this light. There won't be any lights. There, and it's possible that lights may have had some role to play in the emergence of life. So, for example, small elements, they lay eggs and die. It's connected to the moon. So it's possible that a lot of things wouldn't have happened if we had. Also, moon is beautiful, right? Less poetry. Less poetry.
And we wouldn't have light in the night.
There won't be anything like full moonlight. Full moon.
So why did any other country didn't go to South Pole of the moon before Chandrayaan?
If you have the money, before that, it's only recently that we have found that.
You can ask. I'll be here. So you can ask.
Just to go to something. What is it?
Why didn't other planets behind life?
Other countries, right?
Yeah, why does it do?
Now they are China. Now they
Don't see any towers like both planets, so they both can share them there.
Also, I also have a question about the sun. I heard that it switches its poles every 11 years, but why does that happen?
sunspot.
No, the sun it switches its poles. At least I heard that.
Sun or moon. Sunspot. 11 years it is sunspot cycle. So we have maximum and minimum sunspots.
But sun doesn't have a pole, right? Sun doesn't.
There are a pole, but I don't.
11. That's what she was asking.
Oh, I see. Okay. It's the magnetic field.
Yeah, magnetic poles.
Every 11 years.
Oh, why?
Yeah. Yeah, I
Give it to Biman.
So, one second. Like, how would it classify
You can say the solar system, you start counting. So. Start counting. 300 plus. Plus, you take all, then there are small ones. Sure. Message.
Basically, was. So I'm really keen in career in that's the first time I've heard that.
You were a athlete or something.
Yeah, but I'm also really interested in this. Narayana.
Yeah, this is a good question that you asked. Why study astronomy?
Yeah,
So
everything is behind one.
So just give them a question.
Yeah.
So like apart from the Milky Way, how does the matter galaxy
Many, like billions and billions. It depends on how far you look. There may be galaxies even beyond what we could be observing. There may be galaxies.
Yeah, correct. That's what it is. Observable.
Please don't forget. Okay, same.
I had a question.
That's common.
Are edges key event? Actually, I had a question. What is the possibility of multiverse? How?
You want Spider-Man in there?
How do I answer this question?
I think
I
that
have
comes
no
in
idea.
picture.
It's a possibility. It's a possibility. But we don't know. Because multiverses are not causally connected. I don't know what is happening in another multiverse. I don't never know.
It's one of the theories, that's all. We're not sure if it exists or not.
Okay, thank you.
It's in 20. It's like 31 minutes. 12:31 more.
Good. Yeah. The question is, you study so much in astronomy and how planets are formed, galaxies are formed, things like that.
I don't know. I'm so much.
No, so my question is, actual question is, how do you stay believer? How does one stay as believer
Say it again. How do I stay believer? Believer in what?
in religion?
How do you know that I'm
No, I'm just asking, many people still believe they're in astronomy, they're like,
I don't think this is connected to religion is a personal belief. I'm personally atheist, but I don't expect others to know to be atheist. It is a personal belief. Right?
Yeah.
You asked the question, right?
Yes.
What's your name?
Catherine.
See,
Yes. Say now. Sure.
Oh, really?
Yeah.
But it telescope at home. Lovely. You've seen the moon?
But one day in March they took and round one day it's half. I think when moon comes out,
Basically, only a part of the moon is being lit up by the sun. Sun's parts of it's getting lit up by the sun. So you see, sometimes it's more person. That's how it is.
So how were exoplanets and what are all exoplanets?
What are means it names?
So, certain planets, I heard that certain planets water was discovered.
Yes.
So how was
Indications. So because it is very difficult to find out what is it there, but you can find out from the atmosphere is it if there's water vapor. Then you
certain planets are extremely far, so how did we realize that?
so you can find at night. And as the planet moves around, its atmosphere is going to be blocked. So you can see the light through the atmosphere.
So both of them. We suddenly realize I
And so
three space soluble. Let's say that double. I B H. SU, CHE,
Sri Sujata and Sri Sam.
Do you want to be an astronaut?
Specifically,
Fifth.
what would you? Your board exam study.
No, my 11th is over, that's for now. Rest of it was the last exam. Last Friday.
Because this board will never be. That's the whole idea of that. So no information is no, we may not know what is inside you. Because of this, you know what's going to happen on the gas, the matter, on the effect is strong. Things are all very fast. All very fast. Very hot. As you know, very hot. Very hot. That's how we study. So we study the lab, study set up. We can figure out must be.
How many satellites are there currently in new orbit and after they low Earth orbit? How many satellites are currently there and after they run out of fuel, where do they fall? But where?
See, they usually fall in different places. I really don't know. They may actually make it fall. So they can, if they can still control it. It's trying to make it fall on the ocean.
Raghav and my sister Raghav. And why don't planets go inside black hole? Yes, I have a doubt as well. How did it stay inside the black hole? How did it stay inside
It doesn't let anything.
How big is the black hole then? It doesn't make everything stay in the something.
Some can also do it.
How does gravity distort space?
That's what gravity is. Gravity is not a force. What that defines as. Gravity, what you say, except that you don't need to think of it like his force. It is basically changing the shape of it.
Like my sister's name
You already it's astrology. Can you
Does Titan have water? Titan.
Yeah. High pressure. I mean, no, but it's not really.
Like why we get how did this so I was trying to find Hi. My heart.
Sister. Or we can same schools.
Yes.
It is supposed to be. That's this. Sorry.
My name is Sadhvi. So actually, I have doubts. Actually, I had the doubt. In page number 8, first paragraph, she wrote that yeah, so you said audio based like actually you might trying to find out how to do it. We are like so sure that it will be very far. Like we're trying to find if we are in the news and like we're trying to find a way to share into the like if we are in like if we are in a legal board.
What's the living body?
No, if the aim all these are parts of the living body, they are trying to find out like what's big. You don't think about
So,
how much past could the university are they trying to find out?
no, the distance is
You know how much past how much she got
So, in the.
so are we trying to know, are we trying to see there is my you know that? Yeah, no. I started reading the manga. Where is it available? Not available. Solo leveling manga I started. Solo leveling. That means me feeling care of the creator. I don't even have one manga. I have two. Actual.
Black holes, probably there are more indications than this. It's your sort of. What she knows white holes?
Yeah.
What is it? It's because I even
Question about black holes.
see, and you've been reading about white holes.
I have a question about black holes.
Yeah, look, it's possibility.
know your interest, like what you want to read.
Famous. I'm amazed. My son didn't read about white holes.
Thank you.
I can give sisters.
Yeah.
And VIP. Here's a link, here's a question also. Oh. Find out when we see one, right? Waiting for the light maintains.
Like the comets will come, like don't, like, as you told, that they leave a track of us. Don't they come and collide with the earth?
They might, and they may have in the past. So they want these events that are possible. The Columbus 1908, it may have been. But then what will happen? The comets will just evaporate. They won't leave any fragments. So that the happens between. But it will also be an explosive event. Oh. Oh. Wow. Amazing. Amazing. Kids, this is. It will stay for almost for long, billions of years. And it's so hot that it's going to slowly cool. But it's going to take billions of years to just cool. So it will remain white. And there are lots of white dwarfs which are very, very because they last for about.
What will happen after the
It's very white. Slowly we just cool. But in the event, and you can see Jupiter's cloud. In some cases, yes. They look like, but they may not have the same composition. It looks like also it doesn't. It has water vapor, but it has other things. It looks like it looks cloudy.
So I really like to
Thank you.
my name is Mihira.
Nihira. It's from Niharika.
What?
It's from Niharika. What is that word from?
Mihira means uniform treasure. I have a question. You said that the crater is formed by the movement by asteroids. So, Has it ever happened that an asteroid has hit the moon and it changed the moon's axis?
It's possible. Good question. It's possible.
പേര് പറയട്ടെ
Son of 20 years.
So that the names can be.
I had given this to Atagala.
Yeah.
The different vendors. Tell me the names again. AIT. Right?
So I have been meaning to ask a question, so I couldn't get the yes. So, yeah, while we all are focusing on the research and discoveries and innovations in the field of space, we forget we are kind of polluting the nature in the process, right? So, at this moment, like kind of right now, I read that the Earth is starting to look like starting to have rings because of the space dust or the space waste we're sending because of the satellites or because of the rockets we're sending to space or the probes. So how are we going to identify the damn thing, or are we just going to let it go?
Well, I think there are concerns and they are trying to bring down some of these messages.
Yeah, that's definitely going on, but SpaceX is working on reverse and looking down into the rockets, yes. But what's going to happen to the ones which is already done? How are we going to reverse the damage?
There is also, I think, attempt, I don't think, but at least some parts to bring junk back.
Are there any chances that the junk is like drifted away to past spaces and it might affect any other process in the space?
I don't know, I have not studied that. This is a big problem. I think become bigger.
Because we all are like focused on innovations, whereas we are getting this in the process.
And should not be just in the innovation.
Exactly. So
But yes.
that's a rising concern, I feel.
Yeah, but nobody seems to care what's going to happen in 100 years.
So maybe we, as the future generation, we might have to focus on that aspect rather than more on innovation. Thank you.
I'm glad that you keep.
So I am a candidate. I'm my first year in the marketing institute. So really, really interested in more research and maybe more discoveries, as well as I work on this part as well. I just want to know if there's any opportunities to, like, I want to start early so that I kind of feel like I'm running out of time and I'm wasting a lot of time. But I kind of feel that this purpose is like, I'm not pursuing what I'm writing because right now engineering is not exactly my aim.
But in studying whatever that course subject, study physics.
Yeah.
Well, right now you should be doing first you should be I can think of there are Last slide. Thanks for patiently waiting. But there are questions. Sitting in?
Thank you for patiently signing so.
No, they have lots of questions also.
One book for you with the.
Thank you.
Stephen.
Sure. Thank you.
सब भागने गए असली हाँ ठीक है डबल एड ईयर आपने कौन आगे इसको ज्ञान शिक्षा ना लिखे सर कि ज्ञान विज्ञान छोटो और आनंद वगैरह অনেক আর্টিকেলও পড়ে দিলেন হ্যাঁ আর আপনি না आज में से पहली बार वो है
The audience for your exams.
There's a white one. So, if anything is able to enter from one side, you also need to right
Some solutions. So something was, yeah, so you would see the white hole, right? So, I don't know what to do. Can you see a black hole in that white hole? This is I'll be saying something.
And the farm is
Why? See, dimensionally, it has to be mass times some speed square. Think like this. It has to be mass times some speed square. What speed is? So say because I'm taking the speed of any, it has to be some fundamental. Speed of light has to be. Einstein proved in many ways why is can look at some of these derivations. During then, right, you should be able to understand some of the animations after you have exams. Here, here, now, here. She's a poet. Can I have this?
Yeah.
Oh, thank you. She just told me, I'm writing, what can I say? All the best for you, sir. Thank you. Thank you. Thank you for being, thank you, sir. Thank you. Thank you for bringing this.
Thank you.
I will cherish this. I will treasure this.
Whenever if you call me and is assigned the question paper.
Hi, Biman.
Oh, hi.
Thank you for coming over.
Come on. Who is this?
It's my niece.
Oh, thank you for my dog.
No, no, it's wonderful. No, 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 I listened to some of reading. It's wonderful. It's got the bestseller. Nishant. Nishant.
He said that.
That's for me, some taste on me too. What?
He remembers. Good, good,
All the
Biman.
best.
Good to see you.
Thank you.
Wonderful action. It's very nice. How full action. Oh, yeah, yeah.
I was, this is
Very,
beyond.
very nice. It's very, very nice.
Thank you.
Okay, see you then.
See.
Yeah, SSC double T. It's okay. It's okay. VA double T. He has so many questions about the system which I can't answer. VA double T.
Double H.
It's,
Double T.
yes, because this is literally the right mapping of the pronunciation which we have.
Is it right?
Yeah, yeah. In the Gita also, that's what it is explaining.
Double T.
Yeah. The tree which was having inverted, you cannot find anything about it. So he is very much interested about solar system, how this universe came, where is Shiva, if you want to see it in the universe.
Which class are you? You're in UKG.
Any other question you
And I'll keep talking to you as I.
have? He is my studies brother. Indian brother.
What's his name? Double A.
Thank you so much for writing this book.
Thank you for bringing your
No,
children.
yeah.
I'm so
The
amazed.
good thing is you have written it in the verse, which I like, right?
I hope it will
That's
at
why-
least resonate with some.
Yes, yes. It can be a bedtime story as well like this, yeah. Thank
All the
you.
best.
Thank you so much, sir. Thank you.
Do you remember me? I'm Gillian. Oh, hi, how are you? See you such a long time. Where did you know? I'm in Nagasaki. You went there, right? Yes. You were in Leo's, right? Are you still there in Leo's? I'm still there. Okay. Nice. It was such a surprise to see. This is your daughter? And this is my daughter, Gauri. The two daughters. So like both of them in this place. You are right. In my CHI, YW. And it's good to see you from all this. Actually, I'm going to the ISRO's ULSCI. What was it? ULSCI. The National Science Day.
Unfortunately, we are at a different, they're in Kenya.
Yeah, right. I remember. It's fine.
Yes, everything is going fine. Thanks. I think in 2000, when I did in RRA, 1972, 95 to 2000. Until the time I joined.
Yes, of course. You were a Raghu student.
I was Suresh.
So, yeah, I met Suresh after last few months ago. He was still in good health.
Yes.
Right. On the best.
Yeah, 28, unfortunately, working there.
Right. Come sometime.
ADPN.